Today is the 30th of June 1994, and this is the first of the lectures on the upper level tech of TROM, and I want to take up with you the subject of insanity. The word insanity, or the word more precisely, the word sanity, comes from the old Latin word sanus, meaning healthy. So presumably insane means unhealthy, but that meaning has long since been modified in English, and the only connection these days between the subject of sanity and the subject of health, we could say that a person who is insane would have an unhealthy mind. That would be about the only connection. There's no other use of the word health, no other connection between the word healthy and the word sane that I know of in modern English. However, it's long been known by mankind that there's a connection between this subject of sanity and this subject of reason. And there's also, it's been known that unhealthy people, and particularly unhealthy people with unhealthy minds, don't reason too well. So there's a connection there, there's connectivity there too. In our modern society, the word insane is largely used in a legal sense. More and more, only the legal profession have a use for this term of insanity, the term insane, and the subject of insanity. The medical profession gave the term away many, many years ago because of their conflict with the medical profession on the subject of what the word means. These days the medical profession talk about psychosis. In the subject of psychiatry they talk about psychoses, etc., which they have some form of definition for. And there they stand. But the subject of insanity they won't have a bar of in its legal sense, and one can understand why. You see, the problem that the law has with the subject of insanity started many years ago, when some bright young barrister pleaded his client innocent of a crime on the grounds of insanity. And once he did this, of course, the legal profession had to have a definition of insanity to find out if the person was on one side or the other side of the line. In other words, they were looking for a definition of insanity. And the law, I believe this was about sometime in the 19th century in English law, they came up with a definition of insanity, a legal definition. I believe they called it the McNaughton Rules, which said that a person, I'm paraphrasing it here, that a person is insane if he doesn't know what he's doing, or if he does know what he's doing, he doesn't know that what he's doing is wrong. That's roughly a paraphrase of the McNaughton Rules, and you'll find that rule, with various modifications, is taken in various parts of England, Australia and so forth, is the legal definition of insanity. Also many states of America have adopted it, or very similar rules, but very similar definitions of insanity. But quite clearly such a definition of insanity is useless from a medical point of view, and that's why the medical profession simply won't have a bar of it. They're quite happy with the term psychosis, which they can fit into a medical structure. They can't fit this definition into a medical structure, the legal definition of insanity, into a medical structure, so that they have no use for it. Well, quite frankly, neither can we. Well, we can't use the legal definition of insanity either. The lawyers and solicitors and the legal eagles might be able to make sense of this definition, but it's a completely useless definition for a social scientist, for a psychologist, as it is for a medical doctor. It's quite useless, and so we must abandon it too. It's of no use to us when we're talking of the subject of insanity. Nevertheless, if we want to understand the subject of insanity, we ought to have some form of definition for it, which means we've got to hang it onto something. We've got to connect it to something. We just can't have it hanging there all by itself in space. We've got to define it. To define it, means we've got to connect it to something else in the universe. Well, the thing that insanity or sanity connects itself most obviously to is this subject of reason. That is the thing it's most obviously connected to. It's, as I pointed out earlier, that it's been well known that insane people do not reason very well. They reason very, very badly. And people with unhealthy minds reason very badly. It's been well known this for many, many centuries. This is so. So the most obvious connection, most obvious thing to define sanity and insanity is in terms of reason, and that is what we do in TROM. We don't talk about health and healthy minds, but we're very much concerned with the subject of reason and so forth. Now, in TROM, we know. Now, this is not an original. It's not an original discovery in TROM, but we know in TROM that reason in this universe is based upon this proposition that a thing cannot both exist and not exist simultaneously. Now, that is a definition of reason, a basis of reason in the whole field of logic and in the whole of the sciences. The whole of science accepts that as a basis of reason. That is the basis of reason. In fact, the whole science of logic is based upon that premise that a thing cannot both exist and not exist simultaneously. So that is reason in logic. It's a subject of reason in science, and it happens to be the subject of reason in the universe at large. When the scientists and the logicians adopted that as their basic premise of reason, and based the subject of logic upon that, they were on very, very firm ground, because it turns out that the proposition that a thing cannot both exist and not exist simultaneously is a valid deduction from the basic law upon which this universe is evidently constructed. So we're on very, very firm ground in TROM when we say, okay, we're going to start relating this subject of sanity to reason and insanity to unreason. Now, once we do this, we've completely left mankind at large behind, because mankind at large, as you probably know and have noticed, has almost as many definitions of insanity as there are people. You know, it's an incredible thing if you go up to a person and say, well, what do you think, what is insanity? And you'll get as many different answers as there are people. Now, the reason why you get this phenomena, is that nobody knows what reason is. You see, if you don't know what reason is, you won't know what unreason is. And if you don't know what unreason is, you're going to have trouble with this subject of insanity, because of this obvious connection between the subject of unreason and insanity. Now you see why mankind has trouble with this subject. The end point that mankind gets onto the subject of insanity is that the final end point is, he says, well, any person who disagrees with me is insane. Now that's the final fling of the compulsive games player. You know, if you disagree with me, you must be sane because you disagree with me, and I'm sane. I'm obviously sane. Therefore, if you disagree with me, you must be insane. And that's the final step there of the compulsive game player. But as this might be a method of settling games. It might be a very, very valid idea of getting rid of the opponent. I mean, in the history. In history shows us a vast number of occasions where people who've disagreed with the establishment have been clapped away in insane asylums, or maybe even executed, or simply because they've disagreed with the establishment. They've been pronounced insane, vanished. They've gone, never to be seen again. It is still happening today on the planet. You know, you can go to various countries in the third world, and anybody who disagrees with what the president says, he publishes his disagreement with the president, what the president says, and the following day the man's gone, never heard of again. You know, his body's dumped out at sea somewhere. That's it. You know, so he's gone. Obviously insane. Don't want him. He disagreed with what the establishment said. You see, this is what the games player considers as reason and unreason. The man is obviously insane because he disagrees with me. This is about as far south as it can go. It's about as unreasonable as you can get on the subject of reason, I can assure you. Because we know what reason is. It's got nothing to do. Reason has got nothing to do with might being right. It's got one hell of a lot to do with whether a thing can both exist and not exist simultaneously in the universe. You get the drift of what I'm onto here. Mankind at large doesn't know anything about this subject. Only the scientists know a bit, because they've studied logic. The logicians know about it. They know a bit about reason. The scientists know a bit about reason, but mankind at large doesn't. People who've never studied science or studied logic, studied mathematics, have no vaguest idea of what reason consists of. Really, they don't. They have no idea. Outside of this field of natural philosophy, the person has no idea of what reason consists of. That includes the law, that includes business people, businessmen, so forth. They simply have no idea. It's no part of their training. So they have no concept of what reason is. So they have no concept of what insanity is. So of course they can pick any wild idea out of thin air and say, well, that's a good definition of insanity. You see that? And that's what happens in our society all the time on the subject of insanity. There's almost as many definitions of insanity as there are people, simply because people don't know what reason is, and if they don't know what reason is, they don't know what unreason is. If they don't know what unreason is, they can't connect it up to the subject of insanity, so they can't get a good definition of insanity. But we can do better than that. Now, I had to give you this little digression because you may believe that our society knows a lot about insanity. In truth of the matter, it knows nothing. It knows nothing about insanity. Simply because our society at large doesn't know anything about reason. It can't define it. You go up to a person and say, what do you think is reason? What's the definition of reason? He can't tell you. He doesn't know. Yet he will call himself a reasonable man. You say, are you reasonable? He says, oh yes, I'm a reasonable man. You say, okay, well what is reason? And he can't answer the question. Now that's a very strange state of affairs, isn't it? That a man will call himself reasonable when he can't define reason. How unreasonable can you get? That's just about as unreasonable as you can get, isn't it? But enough of this digression. Let's get back onto the main road. Well, now we're ready, really, now to give our definition of insanity. We're in a position to do it. We've tidied up with the subject of reason. We know what reason is, so we know what unreason is, so we can define insanity. And this is what I'm going to give you is the definition of insanity that we use in TROM. Here we go. A person is insane when they believe that a thing can both exist and not exist simultaneously. Now I'll just check that back, it's not garbled, so there's no need for me to repeat it. That is the definition of insanity that we use in TROM. A person is insane when they believe that a thing can both exist and not exist simultaneously. Now as you listen to the definition, it doesn't seem particularly world-shattering, does it? I mean, the earth didn't move under your feet as I read it to you, but that nevertheless is the definition of insanity. That is the definition of insanity. It ties it up completely with the subject of unreason. But although it's doesn't sound particularly earth-shattering. As we proceed to tie it up to our existing technology on the subject of games play, I can assure you the dating will become more and more earth-shattering. Until you will actually start to almost feel the planet move under your feet when you start thinking about this subject. Now the first step on this road is what we might call, and is probably very correctly called, the prerequisite for insanity. The prerequisite for insanity. And again, this is not understood outside of TROM. By the way, that Scientology had no definition for insanity. Note that. We have a definition in TROM for insanity. Scientology had no definition for insanity. You can hunt through Ron's works. He never bothered to define it. I don't think he ever really came to grips with this subject of reason, unreason, and insanity himself. Certainly not closely enough to define it within his subject. But nevertheless, we've come to grips with it, and we can define it. But as I say, there is a prerequisite to this subject of insanity, a very interesting prerequisite which ties it up to the subject of games play. Now here's the prerequisite of insanity. Here we go. A person only goes insane when they believe that they have no class to go into if they are overwhelmed in games play. I've just played that back, it's not garbled. Now what do we mean by that? Well, it's pretty self-explanatory, isn't it? A person can only go insane if they have no class to go into if they're overwhelmed in games play. In other words, a person can reduce their postulate set down to 2 games classes. And while they've got 2 games classes, they're okay. They can go into 1 games class and lose the game, and they'll get driven into the other games class, and they're still okay. They've got a game they can play. But what happens if they reduce their set down to a single game class set? Now this ties this up. We tie this material up with what I mentioned, I believe, on supplementary tape number 3. This subject of the postulate set and the reduction of the postulate set of the goals package, reductions of the goals package. You recall that material? It's there on supplementary tape number 3. But if the goals package or more correctly the postulate set is reduced down to a 1 game class postulate set, and the person is using this postulate set in games play and is actually in this games class and actively playing a game from this sole remaining games class and loses the game, gets driven into overwhelm, he has literally no place to go. You might say, well, he'll simply go into one of the other games classes. No, he can't, because he's postulated that he can't go there. His last overwhelm said no. His last overwhelm, when he last left that class, he said to himself, I can no longer play this game. I can no longer stay in this game. I've got to get out of this game. It's not playable by me anymore. So he reduced that possibility down to 0. Now the last possibility is reduced down to 0. So where is he going to go? Well, I'll tell you where he goes. He goes insane. He loses his marbles. And that's what happens. That's the connection between insanity and compulsive games play. And it's a tremendously valuable connection. Once you grasp it, all sorts of things start to make enormous sense. It tells you immediately that only compulsive games players go insane. And it also tells you that every compulsive games player, given enough time, will eventually go insane. Once the person reduces the goals package down to 2 games classes, that's the state of compulsive games play. Eventually it's going to get reduced down to 2 games classes, then it gets reduced down to 1 games class, and at that point every time he plays he starts to use this class in games play, he's putting his sanity on the line. Because if he loses the next game he loses, he's lost his sanity. He's gone. There's no other place he can go but into insanity. And our problem is to put forward the scheme to show how this occurs, and to put it and to get it all written down and so forth, so it's understandable, so you can see it clearly. And it's not an easy thing for me to do, because we're dealing with the very essence of unreason. Don't kid yourself that I wouldn't be giving you this data if I didn't know that with absolute certainty that it's correct. I first discovered this data some years ago, but I put it on the back burner for further and further testing. I wouldn't go off half-cocked. But now I'm absolutely certain that this is it, that I've got the data on insanity. I know exactly what insanity is, and it is what I'm saying it is. That right at the heart of every insanity you find in a person, right at the heart of every insanity, you will find this urge to make a thing both exist and not exist simultaneously, or the urge to try and operate on a postulate and its negative simultaneously. One way or another, the insane person is trying to do the impossible, and it is impossible. It defines the impossible in this universe. It is this attempt to try and work on a postulate while working on its negative, to operate on a postulate while operating on its negative. You can't both go to China and not go to China simultaneously. If you try this, you will go mad. That is insanity. You get it? Now, another datum that immediately falls out the hamper once we know this prerequisite for insanity is the practical thing of how can a person proof themselves against insanity. Now, we know how to do this in TROM. We know how we can proof a person, how a person can proof themselves against insanity, but it's not understood in any other field of psychotherapy. It's not understood in Scientology. Just generally known in Scientology, if a person is cleared that they won't go mad, but it's understood why. We know why. We can explain why it is. So we're running on a senior datum here than the other psychotherapists, because we can correlate this material so closely because of our quite profound knowledge and understanding of games play. So how can we prove a person against insanity? Very, very simply. There's a very, very simple way a person can be proved against insanity. All they have to do is to do levels 1, 2, 3 of TROM, solo. That's all they have to do. Anyone who's achieved the first 3 levels of TROM, they prove themselves against insanity. Why? Because by the time the person gets to the top of level 3, they are no longer a compulsive game player. They've taken so much charge off their game compulsions that their game compulsions are now no longer game compulsions. They play games still, but the compulsion's gone, the charge is off it, the intensity of charge is off their bank by the time they get to the top of level 3. They've taken enormous charge off their case, and they're no longer a compulsive games player. And because they're no longer a compulsive games player, they have no danger of ever going insane. They cannot be driven insane in life any longer. They can be made miserable, but they can't be driven insane. Your compulsive games player can be both made miserable and driven insane. And the proofing of the individual is the first 3 levels of TROM. A person doesn't have to go as far as level 4 or level 5. They don't have to erase all the goals packages in their mind. Oh no, that's not necessary. Just levels 1, 2 and 3 completed solo is sufficient to prove any person against insanity. Now that is a tremendously important datum. And it's the datum that stems directly from our understanding of how insanity comes about. Quite clearly, if a person is not a compulsive games player, they haven't reduced their games down to a single game class. And if they haven't reduced their games play down to a single games class, then they're not putting all their eggs in one basket, are they? And they haven't got all their eggs in one basket, that they can suffer overwhelm, and they'll always have a place to go to. They'll always have a class to occupy in the event of overwhelm. Unlike the compulsive games player who's reduced his games classes down to one. If that one gets overwhelmed, he's got no place to go except to lose his marbles, which he promptly does. Now, I want to give you an example of this, and you'll see it very, very clearly. You'll see how this will go. I'll go through an example and work the example through with you very, very carefully, and you'll see exactly how the person goes insane, and we'll relate it exactly to the postulates involved. But before I do so, I have probably just a little bit of bad news for you. In order to truly understand the subject of insanity, we need enormous precision in our reasoning, which cannot be obtained by the use of just words. So in order to achieve this precision, I have no choice, I've got to use the algebra of logic, which is Boolean algebra. So I will have to lapse into this symbolism. I'm sorry, my apologies, but if I attempt to do it otherwise, I'm simply going to fail, and the whole tape will just degenerate into a massive verbiage, and I won't get my point across. So I'm going to have to use logical symbolism. So that means I'm going to have to define my symbolism as I go and explain exactly what the symbolism means. Then you can grasp it. It's not a difficult subject. I'm not going to turn you into a logician or anything like that. I'm just giving you the absolute fundamentals of it there, so you understand the terms and can see it in terms of the symbolism. Einstein had the same problem with his relativity theory. It's generally recognised that it's quite impossible to explain relativity theory, Einstein's relativity theory, in words to anyone. But once a person understands sufficient advanced mathematics, it's quite understandable. They see the mathematics and it all makes sense. But when they try and put it into words, they can't put it into words, but they can see it in terms of the mathematical symbols. This is simply because the mathematics is a much more precise tool than the English language. And it's similar, I'm up against the same problem, trying to explain and discuss the subject of insanity and so forth, while just using words. The words just aren't precise enough. I will have to lapse into the symbolism of logic in order to achieve the precision required to get the job done. So my apologies, but I do have no choice. Up to this point I've got through. I've managed to write the write-up of Trom. I've given all these supplementary lectures, and you've only had just a nodding acquaintance with the algebra of logic. I've just mentioned it, and just a few bits and pieces here and there. But now I'm afraid I'm going to have to go a little bit further into it and explain a little bit more of it in order to complete this upper level tech of Trom. It's a complicated subject, and we need the precision of the algebra. So here we go. First of all, I'll give you the symbolism that I'm going to use, and then I'll discuss some of the relationships and so forth, and their deductions one from another. But first of all, the symbolism. So we can actually, somebody actually listening to this can actually write it down on paper and see the symbolism. When we put down a symbol, say X, that really means x exists. If we want to put down not x, we write that down as 1 minus x. And because it's, in other words, all we're saying there is that the absence of x is everything in the universe except x. So it's x exists, x doesn't exist is 1 minus x, the whole universe less x. See that? It's quite simple symbolism. Normally, for convenience sake, we surround the 1 minus x with a bracket. So when I'm going to give you 1 minus x, I'll give it to you in the form bracket 1 minus x, end of bracket. Get that? So that's what a 1 minus x will sound like when it comes over to you. Bracket 1 minus x, end of bracket. Now, there's going to be nothing else inside the brackets except 1 minus x or 1 minus y, and so forth. It will just be 1 minus sign, a symbol. That's all that's ever going to turn up in the brackets. So there's nothing complicated inside the brackets except this 1 minus the symbol. That's all that's going to be in the brackets. Right, next is the signs that we're going to use. First is the equal sign. Well, the equal sign's in arithmetic, and we use it in logic exactly the same as it's used in arithmetic. It means identical. Equal sign means identical with. So equals is just exactly the same meaning as used in common arithmetic. But we use another sign in logic, and that is the sign of not equal to. Not equal to. And the sign we use for that is the ordinary equal sign of arithmetic, but we slash it through with a line 45 degrees to the horizontal. It slashes through the equal sign, so it literally crosses it out, and that is the sign for not equals. Now, fundamentally in logic, the statement or the sign not equal simply means that equality is not the case. That's what it means. Equality is not the case. It's not equals. See, equality is not the case. That's all it means. Now, in the logic, 0 means the same as it does in ordinary arithmetic, ordinary algebra. It means nothing. Zilch, nothing, 0. 1, the figure 1 in logic means universe, or more precisely, the universe of discourse. It's the totality of the existence classes. It's the totality of things that can exist in the situation. That is, we express that with the figure 1. So the only numbers that appear in the logic are zeros and ones. We don't have any other numbers. It's a much more simple mathematics than ordinary mathematics, I can assure you. Now, on lecture 10, I've already explained the subject of classes and common classes and so forth, so I don't have to give you that material again. That's already given on lecture 10, which is a forerunner to this one and a necessary prerequisite to this one. So you have the subject of common classes, so you know what a common class is, and so on. Now, I'd better also at this point give you the meaning of the plus sign in logic. The plus sign, it's slightly different from its use in ordinary arithmetic and algebra. In logic, the use of the plus sign depends upon what's on the other side of the equation. For example, if we have, say, x plus y equals 0, it means that both x and y, both x equals 0 and y equals 0. And the combination of x plus y equals 0 means that both of them equal 0. Get that? So x plus y equals 0 means exactly the same as x equals 0 and y equals 0. We put them together and say x plus y equals 0. But when we say x plus y equals 1, we can't use that additive when they're equal to 1, when they're equal to the universe. X plus y equals 1 has the meaning that the universe either consists of x or it consists of y, or it may consist of both. It's indeterminate. We'd have to do something about that equation. It may consist of both. In other words, it's an either-or situation, but we don't know whether it's the inclusive or the what they call the inclusive or the exclusive or. So we don't know. But it's certainly when we have an equation equal to 1, the plus sign is quite disjunctive, it's quite separative. We can't just add them together like we can in arithmetic. Quite disjunctive. It's definitely an either-or situation. It's either x or it's y or it's both. That's the way it's generally interpreted in logic, the equation x plus y equals 1. Now, what about the equation x is not equal to 0? Well, that means that x is not, it's somewhere in between x is equals 0 and x equals 1. It certainly doesn't mean that x equals 0, and it certainly doesn't mean that x equals 1. It's in between. Really what it means is that some x's do exist. See that? It's not the case that x doesn't exist. That is precisely what x is not equal 0 means. It means it is not the case that x doesn't exist. X may be equal to 1 in those circumstances, we don't know. But it is not the case that x does not exist. Now that's what x is not equal to 0 means. A little bit complex until you get to grips with it, but the use of that not equal sign. But I can assure you it all makes sense. It's only, by the way, in the last 50 or 100 years or so that the logicians have got out the use of these signs and got them and brought them to the precision that they are today. The history of logic is a very fascinating history if you'd like to read it up. It's the history of how not to do it. It's taken. There's no more precise subject than logic. And when you read up the history of it, it's quite amazing how many great logicians have got it wrong, particularly on this subject of what is meant by the sign, what is meant by the not equal sign, and how we interpret the question of sum in logic. Well, we can do it in modern logic, but they couldn't do it 100 years ago, but we can do it today. It must be clearly understood that the sign, say, x is not equal to 0 is the complete antithesis of x equals 0. You see that? It's the antithesis, it's the complete opposite. The opposite of x equals 0 is x is not equal to 0. The antithesis of x equals 0 is not, repeat, not, x equals 1. See that? If x is not equal to 0, x may equal 1, but we just don't know. But it's certainly not equal to 0. And that we express that by saying x is not equal to 0. See that? Or put out another way, that some x's do exist. That's another way to look at it. Use the word some. Okay, now what about x plus y is not equal to 0? Well, the easiest way to understand x plus y is not equal to 0 is to realise that x plus y is not equal to 0 is the antithesis, or the opposite of x plus y equals 0. That is to say, it means that it's the antithesis of x doesn't exist and y doesn't exist. It's the antithesis of that. So it means that either some x's exist, or some y's exist, or some of both exist. With the added implication that it may be the case that x equals 1, or y equals 1, or both x and y are both equal to 1. That can be the interpretation of it. X plus y is not equal to 0. It simply means that it's not the case that x plus y equals 0. Pass. Well, that's the end of the That's the end of the snappy basic course in Boolean algebra. We're now going to press on with our material, and it's time that we took up this example that I mentioned to you, so we can understand more clearly how this subject of insanity comes about and exactly what it looks like when it does come about. Well, we're now in a position to do this because we're now in a position to use our symbols, to use our symbolism very, very precisely. Now, for our example, I'm going to use the example that I gave in the original write-up of Trom about the Barber of Seville. Do you remember the example I gave of the Barber of Seville? Which is a well-known historical logical paradox, actually. And I'll just refresh your memory. Remember the barber, the king who he's in this town. There's the king there and the barber, and the king gets fed up with seeing the men of the town wandering around with scruffy beards, so he puts a notice up in the town square, which says that henceforth, on pain of death, all the men of this town will be clean shaven. All those, only those who don't shave themselves, will be shaved by the town barber. Later on in the day, the town barber saw the notice and promptly went insane. Now, why did he go insane? Because he couldn't obey the edict. So he was facing execution by the king, and so he went. The only thing he could do, he went insane. Now let's examine exactly what the problem is here. In order to take this problem apart, the easiest way is to start to put our postulate set together and tick off the possibilities. Clearly, we've got a postulate set here of a person. Let's nominate S. The letter S is a person who shaves themselves, and the letter B, that is a person who is shaved by the town barber. So it's the S. We're looking at the SB postulate set. Clearly they are postulates. To shave oneself is a postulate, and to be shaved by the town barber is a postulate too. They're both postulates. So it's a postulate set we're looking at here. Then both postulates aren't in the same goals package, so there's a bit of cross packaging going on here, but nevertheless it's still a postulate set. But it's not a goals package as we would understand it, but it's certainly a postulate set. Now, first of all, let us write down all the possibilities in this set. Well, there's the four possible classes. There's SB, S, bracket, 1 minus B, end of bracket. Bracket, 1 minus S, end of bracket, B. Bracket, 1 minus S, end of bracket, bracket, 1 minus B, end of bracket. They are our four classes that we recognize, and we're going to add in this class which we'll call an insanity class. We will add it into the set and we'll see how it fits in. This is the class of B bracket 1 minus B, end of bracket. And for completeness sake, we'll add in another insanity class of S bracket 1 minus S, end of bracket. So we have in all 6 possible classes here of our set. Now, normally, if we were doing a logical analysis of this particular problem, we would simply restrict ourselves to the first 4 classes. The last 2 classes will be made equal to 0 by the basic law of reason in the universe, which says that that b bracket 1 minus b end of bracket equals 0, and s bracket 1 minus s end of bracket equals 0. By the basic law of reason in the universe, that both of those classes would be null classes, so they can't be cancelled out. But we're going to leave them in for the sake of completeness, because we're dealing with this subject of insanity, you see. So we've got to put them back in again. So in they go. So we've got 6 classes. Actually, there always are 6 classes in the set. When there's 2 elements in the set, there's the 4 main classes, then the 2 possible insanity classes. But we normally, as I say, the 2 insanity classes aren't used because we're not dealing with the subject of insanity. Normally we're dealing only with the subject of reason. But as we're on this tape, we're dealing with the subject of insanity. We're going to have to put the extra insanity classes in and complete the set. So we've got 6 classes, okay? And we're going to leave the b bracket 1 minus b class in and the s bracket 1 minus s class in. We're going to leave those in. We're not going to make those equal to 0 because we're going to try and understand how this guy went insane. So we can't make those classes equal to 0 and cancel them out of the set, because one or the other or both of them might be useful in the analysis. So we'll have to leave them in. Okay, off we go. Now let's start ticking off the classes. The first of the let's have a look at what the king said. But before we take up what the king said, there's 2 things we actually should do first. One of these is, from a practical point of view, we should number our 6 classes from 1 to 6. So we'll just, I'll assume you've got them written down, and just number them in order like I gave them to you, from 1 through to 6, starting with the reason classes, and 5 and 6 will be the 2 insanity classes. Okay, so just number those 1 to 6. Now the next thing we have to do to realise this analysis, we're only really concerned with the town barber. We're not really concerned with the men of the town. So we'll restrict the analysis to how the king's edict affects him, because it clearly, if you care to look at it, you'll see that it affects the men of the town quite differently than it affects him. So we're only concerned in the analysis with how it affects the town barber. Now, before we go on to discuss what the king said and see how that affects the situation, we must first of all discover if there's any limitations to the set by the very nature of the postulates themselves. And when we examine this, we find that is actually the case, that this town barber doesn't have a full freedom of choice, even regardless of what the king said. For example, it's quite obvious that if the barber shaves himself, he is being shaved by the town barber. And it's equally obvious that if the town barber is being shaved by the town barber, he is shaving himself. Now, there's 2 propositions straight away that affect the set. Now, the first of these propositions, if the barber shaves himself, is being shaved by the town barber, knocks out number 2 in our set. S bracket 1 minus b end of bracket. That goes out. And the second of these propositions knocks out number 3 in the set. I won't give you what it is, but you just knocks out and reduces number 3 to 0. So the town barber has got a reduced set straight away, regardless of what the king said. He's only got 1 and 4 plus the 2 in possible insanity classes. So he can either shave himself and be shaved by the town barber, or not shave himself and not be shaved by the town barber. There is only options. They're the only options. So they are his options as he approaches the notice board and reads the notice in the town square about the king's edict. Bear that in mind. That's it. They are his only options. Now let us consider the king's edict. The first thing the king says is that henceforth, on pain of death, all the men of this town will be clean shaven. Well, what he's saying here is that this class number 4, the class where the person neither shaves themselves nor is shaved by the town barber, that class is reduced to 0. Get it? So we imagine the town barber, he reads the edict he reads that first part of the edict, is, oh yes, on pain of death, all the men of the town will be clean shaven. Oh, he says, well, I'll have to shave myself. I can't grow a beard anymore. See? So he's okay so far. So 4 goes out, so that leaves him with just 1. He's only got now 1 class he can occupy in the sanity part of the reason part of the postulate set. That is to both shave himself and be shaved by the town barber. Now notice now that his set has been reduced to a 1 game class set. One game class set. Remember, this is not a gold package, but nevertheless the same principle applies. That we started off with 4 classes in the set, in the reason part of the set, and we've now got it down to 1. There's only 1 reason class that he can occupy in that set. And that is to shave himself and be shaved by the town barber. Okay, so the barber now reads on. Now the next part of the king's edict says, all those and only those who don't shave themselves will be shaved by the town barber. Now there's 2 propositions there. The first of these propositions is that all those who don't shave themselves will be shaved by the town barber. Now this proposition means, we interpret that to mean that number 4 of our set goes out to 0. Yeah, that's right, number 4. The king is simply being repetitive. That proposition means exactly the same as saying that henceforth all the men of the town will be clean shaven. As logically, they mean exactly the same thing. Now, when you're doing a logical analysis, it's not at all unusual to find the person's utterances, what the people say, are highly repetitive. That's okay. It doesn't affect the analysis. You say, okay, well, number 4 now definitely out. That's definitely equal to 0. Now that leaves us with the final part of the king's utterance. Now the final part is, only those who don't shave themselves will be shaved by the town barber. Now this proposition, only those who don't shave themselves will be shaved by the town barber, means exactly the same as saying that all those who are shaved by the town barber won't shave themselves, which in terms of our set reduces class 1 in the set to 0. Now up to this point the barber has read the edict and he's been okay. He's read the first part of the edict about men in the town being clean shaven. He says, yeah, that's all right, I'll have to shave myself. He reads the second part of the edict, all those who don't shave themselves will be shaved by the town barber. He says, yeah, that's all right, that's fine, I'll shave myself. And then he gets to the third part of the set, only those who don't shave themselves will be shaved by the town barber. Crunch, bang, he's in trouble, because now his final remaining set has been reduced to 0. He can't obey the edict. He is in the SB class, the class of SB, and the edict is driving that class into 0. So the effect upon the town barber is the edict drives him out of his last remaining class, at the SB class, while he's desperately trying to stay in the class. Now let's take a pause here for a moment and understand exactly what the what this unfortunate barber's problem is, or another way to look at it is what his problem isn't. He doesn't have any problem shaving himself. That is not his problem. He has no difficulty on this subject of shaving himself. So this little insanity class of S bracket 1 minus S end of bracket number 6, we can reduce that to 0. That we can wipe that one out. That's not his problem. So that one goes out. No, his problem is the fact that he's the town barber. Because if he weren't the town barber, he could shave himself. It's only because he's the town barber that he can't shave himself. The edict prevents him from the edict only prevents him from shaving himself because he's the town barber. You see that? So his problem is that he's the town barber. So you understand that he has no problem shaving himself. His difficulty is on identity. It's an identity problem. So it's this question of being shaved by the town barber that is the root of his problem. Being shaved by the town barber, or not being shaved by the town barber. If he could not be shaved by the town barber, he'd be all right, you see. He'd be all right, you see, because he could then shave himself and not be shaved by the town barber. But he can't do that while he's being the town barber. You see his problem? It's an identity problem. So as he stands there looking at the notice board, his mind will go from must be shaved by the town barber, but I can't be shaved by the town barber. Which is when he says I can't be shaved by the town barber, it's just another way saying mustn't be shaved by the town barber. So his mind goes from must be shaved by the town barber, but that's impossible because the edict says I can't be. So I mustn't be shaved by the town barber, but that's impossible too because I'm the town barber. So I must be shaved by the town barber, but no, the edict won't let me. So I mustn't be shaved by the town barber. Well, but I am the town barber. So it must be shaved by the town barber, mustn't be shaved by the town barber, must be shaved by the town barber, 1, 2, 1, 2, faster, 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 until he hits the point of must be shaved by the town barber and mustn't be shaved by the town barber, both postulates simultaneously, both with the same intensity, bang, at which point he loses his sanity. Now, if you can follow that, you've got it. So our set now reduces to the first 4 classes are 0, they're all 0 classes, and class 6, we've agreed that is a 0 class, and the 5th class is 1, is existence class. He's now in the insanity class of both must shave himself and mustn't shave himself simultaneously. Now, factually, this may solve his problem for him as far as the king is concerned, or it may not. The king, I mean, obviously, while he's insane, he's going to grow a beard. So the king, if he was harsh, he might say, "Well, we'll execute him anyway. He didn't obey the edict." Then again, the king might take pity on him because he's insane, and relent, save his life. So it may or may not solve his problem, but nevertheless, that's what's going to happen to him. He's going to go insane. Or to put it another way, while he is fixed in the identity of the town barber, insanity is his only option in the situation. It's his only option because it's the lesser evil to being executed. That's the other option, but that's a worse evil. So he will accept the lesser evil and lose his sanity. Of course, he would have had no problem at all if he hadn't have been fixed in the identity of the town barber. Let us assume that he was a non-compulsive games player and had completed his first three levels of Tron, and so could have occupied the identity of the barber, or the town barber, or not. He could be the town barber or not be the town barber at will. Then he would have no trouble at all. He would he would have simply read the edict and said, "Okay, What'll happen is, he said that while I'll shave myself. When I shave myself, I won't be the town barber. But when I'm shaving other people in the town, the other men in the town, I'll be the town barber. So he goes back to his end of problem. So he would have simply gone back to his barber's shop, noticed that it was full of customers, put on his identity of being the town barber, and proceeded to shave them. Then when he got rid of all his customers, he would have simply removed his identity of the town barber and hung it on the hook in the barber's shop, and then he would have shaved himself quite leisurely. And then when he got himself shaved, he would have put his identity back on of the town barber, all ready to receive the next customer. Now I can assure you that you now, if you've been following this through carefully and closely, you now know much more about that logical paradox than the guy who dreamed it up. I can assure you, because you now know all about the insanity side of it, which he obviously did. He clearly never knew. So you know one hell of a lot about that logical paradox. But we can see how useful that little logical paradox was to us, because it gives us, by using it, we can use it to understand how a person goes from a compulsive gameplay into insanity. Now, this class, we'll call it the general class of x bracket 1 minus x equals 1. Now that is what we call the insanity class. Now that's a definition. That is a definite term. We call that an insanity class. And it's also, we have a name for it in Tron, which is a more generally used name. We call it an IP. Now IP, letter I, the letter P, they are the initials of impossibility point or insanity point, IP. So when we try, an IP is always in the form of x bracket 1 minus x end of bracket equals 1. It's the essence of insanity, the very basis of insanity, and that's the general expression of it, is x bracket 1 minus x end of bracket equals 1. And the IP is short for insanity point or impossibility point. It's impossible. It's an impossibility point because in this universe it's impossible to maintain that class and retain one's sanity. Quite impossible to hold that class. So it's a point of impossible. In other words, it defines the impossible in the universe. The only thing that's truly impossible in this universe is the IP, is x bracket 1 minus x end of bracket equals 1. That is truly impossible. It's the only thing that's impossible in this universe. You simply can't do it. It's the only thing that can't be done in this universe. You can't both go to China and not go to China simultaneously. You can't both be the town barber and not be the town barber simultaneously. It is impossible, and it's the only thing that's impossible in this universe, and it's something you should remember and understand very clearly. It defines the impossible. So when we refute that datum and say x bracket 1 minus x equals 1, when we assert that datum, that x bracket 1 minus x equals 1, we are asserting that the impossible can exist. But that's insane. The impossible can't exist in this universe because the laws of the universe say it can't exist. But it can exist, it can't exist. That's insane. We're into insanity. See that? And that's the very basis of insanity. If you was to say to yourself, you can get the idea of insanity, of how an insane person feels by mocking up an IP and getting into it. I wouldn't suggest you do this if you're at all mentally unstable, but if you've completed a few levels of Tron, you can do it without any danger to your mental health. It's simply get the idea that you must go to China, and the idea that you mustn't go to China, and then go from one postulate to the other postulate, then go faster and faster from one postulate to the other, backwards and forwards, until you're holding both postulates simultaneously. At the point where you're holding them both simultaneously, you'll start to feel a sort of a glee of insanity, a sort of a spinny feeling in your psyche. Well, that's the time to quit, because that's when you're going. That's when you're going into the IP. That's the point where you're going insane. You're going into the insanity. So if we understand it so clearly now that we can simulate it. But of course, there's no real danger that you will go insane when you do it yourself, because you're doing it all consciously, you see. But you can simulate the feeling of insanity by getting the idea of going to China and not going to China simultaneously, or the idea of making any postulate and its negative and holding both postulates trying to achieve both postulates simultaneously. It's a spinny feeling. There's a sort of glee of irresponsibility attached to it. It's a certain definite emotion that's attached with, that goes with the IP and trying to achieve the IP. It's the emotion of insanity. Ron Hubbard knew about it. He called it the glee of insanity. But he didn't know its logical construct. We understand it in TROM. We've got it in TROM. We know about it. But Ron was right when he said there's a glee associated with it. There is. There's a glee. There's a sense of irresponsibility and a glee there, and a definite spinny feeling. A definite feeling as if the world is spinning around under your feet. And you feel as if you might take off into space at any moment. It's a definite spinny feeling. So you can subjectively create the emotion, the feeling of insanity. Now we understand its postulate structure. Now this postulate x bracket 1 minus x end of bracket equals 1 has some very interesting deductions. Very interesting deductions. I'll give them to you. I won't prove these deductions, but they can be. I can assure you that every one I'm giving to you can be proven very easily in Boolean algebra. Here we go. We can deduce from x bracket 1 minus x equals 1 that x plus bracket 1 minus x end of bracket equals 0. In other words, it's a state of affairs where x both exists. Neither x exists nor not x exists. Get it? X plus bracket 1 minus x end of bracket equals 0. Now that's a state of unreason, because the reason maintains that x plus bracket 1 minus x end of bracket equals 1. That's what reason maintains. But unreason, insanity, the IP says that x plus bracket 1 minus x end of bracket equals 0. Now, this is a particularly interesting deduction from our point of view, because it tells us that while the person is in the IP state, the reason part, the reasonable part of the postulate set is reduced to 0. While the person is in the IP state, the reason part of the postulate sets into 0. Take the example of the barber. While he's in the state of both being a barber and not being a barber simultaneously, then b plus bracket 1 minus b end of bracket equals 0. In other words, b equals 0 and 1 minus b equals 0. But look, if b equals 0, two of the four classes in the reason part of the set go out, and if 1 minus b equals 0, the others go out. So the whole set goes to 0. So the person cannot be, if they're in the insanity class, they can't be in one of the sane classes. It's an either-or proposition. Once they go insane, in other words, they can't utilise the other part of the set. In other words, they're either sane or they're insane on this subject. If they're insane on the subject, they're not sane. They can't be both sane and insane in the same postulate set. In other words, if the barber's in the state of B bracket 1 minus B enter bracket equals 1, the rest of the set, the rest of the works, is the rest of the set is equal to 0. And the proof of it I've just given to you, because if x bracket 1 minus x enter bracket equals 1, then x plus bracket 1 minus x enter bracket equals 0. That maintains. That's the first of the interesting deductions. Now, the second of the interesting deductions, that if x bracket 1 minus x enter bracket equals 1, then x equals bracket 1 minus x enter bracket. So x becomes equal to 1 minus x. In terms of our barber, once he goes into the IP of B bracket 1 minus B enter bracket equals 1, then being a barber is identical to not being a barber. There's no difference in his mind between being a barber and not being a barber. The two are completely identical with each other. That's the other deduction from the relationship x bracket 1 minus x enter bracket equals 1. So that's the two enormously useful deductions from that from the insanity class, or the IP as we call it. They're the two valid deductions from the IP. That when x bracket 1 minus x enter bracket equals 1, then x plus bracket 1 minus x enter bracket equals 0, and x equals 1 minus x, or more precisely, x equals bracket 1 minus x enter bracket. The existence equals its absence, and that is insane, I can assure you. That is insanity. Now, once you start to work with these IPs and so forth, you rapidly start to lose your fear of them. The vast majority of humanity are absolutely scared of this subject of insanity. One thing they fear most in their lives is that they will go insane, that they will lose their reason. It's a mortal dread. The games player, or the compulsive game player, I should say, has a mortal dread of going insane. It's as if he somehow senses that he's putting his life on the line, he's putting his sanity on the line every time he plays a game, that he's getting close to the edge. The more compulsive the games player gets into, the hotter as the game hots up, the closer and closer he starts walking to insanity. He doesn't know exactly what's happening, but he senses it's happening. Every compulsive game player knows this. He knows that he's walking close. As the game hots up more and more, he's walking closer and closer to the gates of hell, to the gates of insanity. And sometimes the game player will tell you this. It's written up in books, written up in novels and so forth, written up in works of that men under enormous pressure have said that I walked to the very edge of insanity and just managed to claw myself back at the last moment under extreme game duress. And they write these stories up and they write these experiences up. They're well documented there. But this is the view of the compulsive games player who's caught up in compulsive games play. How about to the non-compulsive games player, or to the person who's completed the levels 1, 2, 3 and Trom and is well on his way through level 4 and 5, or a person who's completed level 5. It's a toothless tiger. There's nothing in it. It doesn't mean anything. He knows the person understands insanity. He knows what it is. He knows its postulate structure. And he certainly isn't going to get involved with it. He isn't going to go around trying to drive himself mad, even if he could. He isn't going to do it. There's no point in it. So to the non-compulsive games player, to the completely rational person, the person who's completed at least the first 3 levels of Trom, and understands this material that I've given there, and understands the nature of insanity, and understands the IP state, and so forth, the whole thing is a toothless tiger. He no longer dreads insanity. He'll sit there and try and go to China and not go to China simultaneously. He'll play it as a game. It doesn't mean anything to him. It's just so much, just another interesting thing to do, you know, try and go insane. I mean this quite seriously. The person, once you understand this material and your state of case, you've cleared off your first 3 levels of Trom and are well on the way, and you understand this material that I'm giving you, you'll lose all your fear of insanity. Just like you'll lose all your fear of your bank. Insanity will go too. You'll find this subject of insanity is not a dread, something you wake up in cold sweat at 4 o'clock in the morning and wonder if you're going insane. No, it's just a toothless tiger. That's the one thing you know that you're not going to do. Get it? So don't think that it's a terrible thing that even a person, you know, when they've completed all their Trom, they've got to be very, very careful not to go insane. No, there's nothing there. There's no charge on it. But put it this way, that when, by the time you've completed the 5 levels of Trom, you can try your hard. You can put yourself on an E-meter, and you can try your hardest to both go to China and not go to China, and nothing's going to happen on that meter except a little tick maybe. Nothing awful's going to happen. You won't even. It'll hardly read on the meter. So you're dealing with a toothless tiger, I can assure you. There's absolutely nothing there. The total danger of insanity is to the compulsive games player. To him, it's a definite hazard. To the non-compulsive games player, insanity is not a hazard. It's not even a problem. And if he understands it, it's a joke. You know, it's a giggle. It really is. It's a giggle. And it's certainly a toothless tiger. There's no monster lurking there in the deep recesses of his mind ready to swallow him up. That's the last monster. I'm giving you the last monster. The last monster in the mind, in the deep recesses of the mind, is the fear that you will go insane. Well, it's a toothless tiger. There's nothing there. If you do your exercises, if you do levels 1, 2, 3 of Trom, plus, then you know this material. Now, I couldn't make it any more clear than this, could I? I couldn't make it any clearer than this. Okay, now the example I've given you of the barber and the barber of Seville is an example which is not one of a postulate. It's one of a postulate set, but it's not an example of the use of this data on the subject of a true goals package as we understand it. Now, I wanted now to give you the full data in terms of a goals package. We'll pick up a general case, a general goals package, the XY goals package, where say X is the to blank postulate and Y is the to be blank postulate. So we're now dealing with the general case in the XY goals package. It's a postulate set still, but it's a very specialised postulate set called the goals package. Okay. Now I want to give you all the reductions in the set and give you the symbolism as we go. So you've got the whole picture. So there won't be any doubt in your mind as to what's happening. You'll be able to write it all down on a piece of paper and understand it. Now the person first enters into the situation there, becomes as a non-compulsive games player. Now he does this by making the postulate x is not equal to y. X is not equal to y. He makes that postulate. That postulate, if he doesn't make that postulate, he could lose the whole set by a complementary postulate, because at any time he can accidentally make x equal to y, and when x equals y, of course the whole set vanishes, as I explained earlier. So to prevent this happening accidentally, he simply makes the postulate that x is not equal to y. Now, let's expand that postulate and see what it looks like. The postulate x is not equal to y becomes the symbolism x bracket 1 minus y end of bracket plus y bracket 1 minus x is not equal to 0. Now all that means is that at least one of those two classes has got members in it and therefore exists. And while one of those two classes has, both of those classes are games classes, you see, and while at least one of them exists, then the whole set won't vanish. So that little relationship there, that x is not equal to y, holds the postulate set in existence and prevents the whole lot vanishing by accidentally making the postulate that x equals y. You simply postulate that x is not equal to y, and from that point onwards the set remains in existence for you, and you can then become a non-compulsive games player in that set. Okay, so much for that. Now the person goes ahead, shall we say, as a non-compulsive games player, and the games play becomes more and more compulsive in the goals package, in the postulate set, until eventually games play becomes compulsive. And at the point where it becomes compulsive, it's made compulsive by the postulate that x equals not y, or in terms of symbolism, that x equals bracket 1 minus y end of bracket. Now, how does that look in terms of the in terms of our symbolism? Well, the set now looks like x bracket 1 minus y end of bracket plus y bracket 1 minus x end of bracket equals 1. See the difference? Before it was that those two classes were not equal to 0. Now they're equal to 1. And while those two classes are equal to 1, they become the whole universe of discourse, the whole universe of the postulate set. So therefore, the complementary postulate classes of x, y, and bracket 1 minus x end of bracket 1 minus y end of bracket, both of these classes can't exist, can have no existence. Of course, the only existence classes are the two games classes. So games play is now compulsive. The person has two games classes. He can occupy either one or the other. He's a compulsive games player with the option of either occupying x bracket 1 minus y end of bracket, or y bracket 1 minus x end of bracket. Let us assume now that games play continues in the universe until eventually he suffers overwhelm of one of his classes. Let's say the y class suffers overwhelm, and in his own mind he considers he can no longer occupy that class. In other words, that he considers now that y equals 0. But as soon as y becomes equal to 0, then 1 minus x must also be equal to 0, because remember, he's made this postulate that x equals 1 minus y, which is the same as saying that y equals 1 minus x. So as soon as he loses y becomes equal to 0, he will also lose bracket 1 minus x into bracket. So y equals 0 and bracket 1 minus x into bracket equals 0, both maintained. So he's now left with this single game class of x bracket 1 minus y end of bracket equals 1. He's now reduced it down to a single game class postulate set. From this point onwards, he's now putting his sanity on the line. Every time he plays with this game with these two postulates. Because if he suffers overwhelm in the game, if he loses the game, he's got to go insane. The only place he's going to be able to go is into the only place he's able to go is into the insanity class, into the IPs. Well, let's say he succeeds for a while, but sooner or later, by the very scheme of things, he's going to get overwhelmed. And what's going to happen? Well, before we discuss what happens, let's briefly just review the position. He made the postulate x is not equal to y. He's made the postulate that x is equal to not y. He's made the postulate that y equals naught, and he's also got the postulate that 1 minus x equals naught. And he's in a games class of x. That's his games class. Remember, that's his last games class is x. And he's got this other postulate there which is bonded to x, because x is equal to 1 minus y. He's got this other postulate of 1 minus y, because 1 minus y equals 1 minus x. So he's in this double class of x, 1 minus y. X is the game postulate and 1 minus y is the exclusion postulate. Now that's his position. Now the opponent's postulate is inexorably driving him from x into 1 minus x. That is to say, the opponent is inexorably bonding x to 1 minus x and 1 minus x to x. In other words, the effect is that the opponent is driving him into the identification x equals 1 minus x. You see, he can't leave x. That's his last haven. That's his last point of he can go in the set. You see, he's got no other place to go, so he hangs on to that grimly, but inexorably he's being driven into 1 minus x as well. But this identification x equals 1 minus x can't take place while he's still holding the identification x equals 1 minus y. Because if x equals 1 minus x and x equals 1 minus y, then 1 minus x equals 1 minus y. And if 1 minus x equals 1 minus y, then x equals y, and the whole set will go. He'll lose the whole lot. The whole game will vanish. That is intolerable. So that can't happen. So he simply has to break the bonding to 1 minus y. The identification that x equals 1 minus y eventually breaks. He breaks that bonding. That snaps. He's now free. The x is now free of the 1 minus y, and the x bonds to the 1 minus x. And we have the identification x equals 1 minus x, quite separate and free of the 1 minus y postulate. Meanwhile, the 1 minus y postulate has been under pressure from the opponent to go into y. And for exactly the same reasons, the 1 minus y, as I've given you a few moments ago, for exactly the same reasons, the 1 minus y postulate breaks its bonding with x and snaps into the identification y, 1 minus y equals y, and becomes the other IP in the set. The set now reduces to x bracket 1 minus x end of bracket plus y bracket 1 minus y end of bracket equals 1, with the player in the IP x bracket 1 minus x. Now why is he in there? Because x was his last games postulate. That was his last sense of self-identity, was the games player using that x postulate. So that's where he sticks, and that's the IP he ends up in. Can he move across to the other IP? No, he can't do so. He can't move across to the other IP, although although it's still a part of the set, but he can't move across to it. But to explain why he can't move across to it and continue on with this tape, we'll have to go on to a new tape because I'm running off the end of the spool here.
And